To get started, it will be useful to have a good orientation in the so-called special triangles. But you will see for yourself step by step without shortcuts, but with thinking. So let's move on to these so-called special triangles. You can't do without knowledge of a square. Let's look at a square like this. Surely all of you know that a square has all sides equal. You can mark them as A, and it also has a diagonal which is equal to D. Maybe some of you know the formula for D. It is equal to a roots of 2. However, I remember from school that it was always hard for me to remember this formula. And at least at the beginning, as soon as these formulas appeared, I counted it many times in the margin in the notebook from the Pythagorean theorem. And this time I will also show you how to calculate it. So let's use the Pythagorean theorem. Let's add the squares of the legs, so that we get the square of the hypotenuse. A square plus a square is 2a. Remember that we want to get the formula for diagonal. To get to this, to get D, you need to take the root on both sides. For the more initiated, remember that roots give the absolute value as a result. But due to the fact that we know that here are positive values, we can skip the absolute value and write that D equals the root of 2a square. This is the longer part. Here we will still have to take a square before the root. So let's do the root for square. I hope you understand what will come out of this and the root of 2, but before let's rewrite. First of all, you can do it in such a clever way that we cancel the root and the square and we get a roots of 2, or write a square to the power of 1/2. In another video, I will explain what powers with a rational exponent work. But here, if you look closely, it also cancels and we get a to the first. That is simply a. But we already have our formula and we know what it looks like. More importantly, we also know that the square, or rather the diagonal of the square, divides one of its angles into equal parts. So here we have then 45. Here we have 45. So if we look at our task, this is where we have such a half of a square. And this D corresponds to this formula corresponds to a square. Because it is also 45, if we look closely, here is a right angle. So it must also be 45, and indeed this is the diagonal of a square. So we already know that this diagonal of a square is 10. And we will be able to calculate from this formula how much it is equal to. And let's write 10 equals a root of 2. This is quite complicated. But not that complicated. We can first get rid of the root of 2. We notice that between a and the root of 2 there is multiplication. So in order to get rid of the number multiplied with our unknown, we have to divide by this number. We get a 10 per root of 2. Such a number is, well, let's say it is in short not pretty. We have to take out the so-called irrationality from the denominator. We do this by multiplying by 1, a quirk. Well, not when if we multiply by 1 we get the same number back. But remember that we can write 1, for example, as 1 over 1. Or, as in this case, it is more convenient for us as the square root of 2 divided by the square root of 2. If we shortened it at this point, we would get this one back. But we do not do this. We just multiply the numerators. The result is 10 square root of 2, and we multiply the denominators. This is the square root of 4, because when we multiply the denominator square root of 2x, the second denominator square root of 2, we get the square root of 4, and we know how to take the square root of this. This is 2. After shortening with the 10 by 2, it gives us 5. We add the square root of 2, which follows us there. And we have calculated at this point, it is here. Let's see on our drawing. It is b, so here we can already enter that this is 5 square root of 2. I unnecessarily used a here b. I could have written b here everywhere. But it seems to me that you have the same in mathematical tables and the same in formulas in the notebook. And additionally, I will mention that in arithmetic, there are often the most different letters in the most different places, and you have to get used to it. And be able to immediately switch in such moments to be able to count correctly. So this certainly will not be this A from my example. You know what? I will even cross out my example with a separate line, so that you know that these are auxiliary calculations that allowed us to actually calculate B. So let's go back further. Since we already have information about B, we know that this is 52. So additionally, we also know that here is 5 roots 2. I hope that most of you know why. But for those who do not know, I will explain that in connection with the fact that this piece was half a square. Here was a diagonal. We knew this from the fact that there are 245 angles. It was a diagonal. It just corresponded to our letter, so here had to be 2 identical sides. In connection with the fact that this is a square, it is the same here as B, and here is also B. That is 5 roots 2. Thanks to this, we can go a bit further. With the task, I will draw here an auxiliary height. And thanks to this, I will be able to notice that this height is still equal to 5 roots 2. But here, I will create another triangle. Triangle 30, 60. In this place, there are 60 degrees. Where do I know that triangles have 180? Due to the fact that here there is a right angle, that is 90. The other two must add up to 90. That is 30 plus 60 is 90. It is very easy to complete in this way. And apart from that, I immediately recognize that this is a special triangle. So let's try to handle such a special triangle. It is an equilateral triangle. An equilateral triangle has all sides of the same length. For the needs of the task, I will draw here the height. And mark the angle 60, 30. Because in an equilateral triangle, the height divides it in exactly this proportion. Apart from that, since this side is long, the height divides it into 2 equal parts. Then in this place there is a by 2, in this place there is the height, we will mark it with the letter. Maybe you know that? Or maybe you have already checked in mathematical tables that h is equal to a roots 3 by 2. I'll tell you honestly that for me it was even more difficult to remember than the previous formula. Here in this formula there was only a root to remember, and I calculated it many times, so it was even worse this way. Here is this formula. Is a bit more difficult. Not only is there a roots 3, additionally you have to divide it by 2. So let's calculate it like before. Where does it come from? We notice here a right triangle. So we can apply the Pythagorean theorem. Let's apply it. The squares of the legs equal the square of the hypotenuse. You can see this here in this drawing. At the right angle there are legs. And opposite the right angle there is the hypotenuse. So let's do the tasks. Here we have h squared. Plus, if we have a fraction raised to the power we exponentiate and the numerator and denominator, equal a square divided by 4. To calculate it correctly and get to a to h, you have to subtract this element. That is, I will subtract a square divided by 4 from both sides. Such an expression is a square. It is really 1. That is 1 over 1 a square. When I subtract 1a 4 square from 4 quarters, I will get 3 quarters a square. It is also worth remembering that if in algebra we have a fraction in the record, the letter right after the fraction is written on the same line as the fraction line, so that this letter does not accidentally fall into the denominator and does not spoil the calculations. We keep an eye on it, so we calculate h. So we have to take the square root. So we take the square root, we get h on this side, the square root of this expression. I notice that only 3 does not take the square root. So I copy it under the square root, while from the remaining numbers I take the square roots. And the square under the square root, as I showed here earlier. As I showed here earlier, it is simply a... So I will write down. And I will also change the next notation so that it looks nice. And the square root of 4 is 2. Hence this formula that I wrote down here earlier. Since I know that h is between the angle of 30 and 90, so I can find my way here. In this triangle there will be h. If anything in this place. So this expression is between the angle of 60 and 90, so it is half a. Between 60 and 90 is half a. And between the angle of 60 and 30 is a, and in our case c. So twice this equals 10, square root 2. Now, what else we have to calculate is the length of our h. Since we know that this longest length in a triangle is 10 roots 2. And in our case it is symbolized by the letter a. Meaning in the example that I gave we can put this 10 square root of 2 into our formula for h. So let's put 10 root 2 multiplied by root 3 divided by 2, 2 and the 10 cancel by 2. And we get 5 roots of 6, because when we multiply roots of this with the same power, we multiply them. 5 root 6, this is h, so in this place we have 5 roots of 6. But this length corresponds only to this length. Here, however, this length corresponds to this length. And we can simply rewrite it. So our a, I emphasize that it is neither about this a nor about this a, but about this a in this trapezoid that we talked about from the beginning, and is equal to 5 root 2 plus 5 root 6. In connection with the fact that both of these are irrational numbers, we simply cannot add them. We can, however, take out the so-called common factor. Before the root, the common factor in both of these numbers is 5, so it lands before the bracket. And in the brackets there are irrationalities. Oh, when I look at it, even the root of 2 is a common factor, so we will repeat these thoughts in a moment. So we also notice, at least I notice after a while, that the root of 2 and the root of 6 also have a common factor, namely here is the root of 2 multiplied by 1, and here is the root of 2 multiplied the root of 3. This root of 2 we can also take out before the bracket. We will cross out our calculations and we will get 5. Roots of 2, 1 plus the root of 3, but I think that even this result would be correct on the test. This one is super correct. Simply such a final, maximally simplified form. So if you liked it, don't forget to like. Thanks for figuring out this trapezoid together. I hope that such a task gives you not only numbers but also satisfaction. Remember to thumbs up, subscribe, and support the channel if you want more content like this or if you want me to help you personally. See you in the next video. There will be another portion of tasks. Or maybe even something from the life of mathematics. Hold on.